Hello, ladies and gentlemen. Today we are doing Pre-Calc Lesson 9, Congruent Figures and Proof Outlines. Congruent figures, they are geometrically equivalent, okay? Which means if you took one shape, picked it up and flipped it around, it would give you the same shape. They're geometrically equivalent. They're the same thing, right? If I put an iPhone 6 on top of an iPhone 6, they would all be the same, okay? Now, we could also define them as similar figures with a scale factor of 1. Is another way to say that they are geometrically equivalent, which is also the same thing to say they are the same, okay? Now we also have triangle congruency postulates, okay? So we have side, 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 angle, side, angle, side, angle, and hypotenuse, leg. Angle, side, angle is the same thing as angle, side, angle, angle, and angle, 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 side. 2 angles are sufficient. Now, what do all of these say? If 2 triangles have 3 sides that are the same, then they are congruent triangles. So if I have this triangle, and these sides are the same, these sides are the same, and these sides are the same, I can say that the triangles are congruent. Or if I have 2 triangles, and I say these sides are the same, these angles are the same, and these sides are the same, they are also congruent. If I have 2 triangles, and I said this angle, this side, and this angle is the same in both triangles, then they're congruent, angle, side, angle. Hypotenuse leg only applies to right triangle, and if the hypotenuse is equal and either leg is equal, we can say that they are congruent triangles. Okay? These are very, very important because I'm going to use all of these things to outline a proof. Okay? So, let me do the first proof for you. I am given that AD is congruent to BD and DC is perpendicular to AB. I want to prove AC is congruent to BC, and I'm given this triangle. Okay. Now, we're going to do what is called a 2-column proof, which means you are going to have your statement on one side and your reason on the other. Always, always, this is what we will do for a 2-column proof. So my first statement is going to be that AD is congruent to BD, and my reason is they told me. It's given. You always start with your given information. So I'm going to put that in, AD and BD. I'm going to draw that. Then the next thing I can do is I can say DC is perpendicular to AB. That is also given, and I'm going to put that right there. Okay. Now, perpendicular means that I have a right angle. Now, I've drawn that, but I have to state that. So I can say angle CDB is a right angle, and that is definition of perpendicular. right? We know that if two things are perpendicular, it creates a right angle. You have to state that, though. There's nothing that is assumed in a proof. It all has to be stated, which means I also have to state that angle CDA is a right angle. Definition of perpendicular. The next kind of duh statement that you need to say is angle CDA is congruent to angle CDB. Definition of right angles. All right angles are congruent to each other. Remember Euclid's postulates that we went over last year? That tells me that I have two right angles that are equal. Now, I can also say that CD is congruent to CD. This is what we call the reflexive property. Reflexive property says that something is congruent to itself. Mrs. Smith equals Mrs. Smith, right? That's a true statement. I am myself. CD equals CD because it's the same line. Now, if I look, I can say now that triangle ADC is congruent to triangle CDB by side, angle, side. I have a side, an angle, and a side. I'm looking at these two little triangles in here. Now, all of this tells me I can say AC is congruent to BC by what we call CPCTC. CPCTC is congruent parts of congruent triangles are congruent. Meaning, if I have this triangle ABC and this triangle DEF, and I say triangle ABC is congruent to triangle DEF, then I can say AB is congruent to DE by CPCTC, right? I said these two triangles were congruent, so that means that their sides are congruent. Their angles are congruent, right? If two triangles are the same, that means that all of their parts are the same. And I would be done. I proved what I wanted to prove. AC is congruent to BC. I've proved that here. I had to go through my givens. I had to go through my duh statements. And you have to state that two triangles are congruent. And you state that by side, 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 angle, hypotenuse, leg. Okay? Okay, I'm going to do another example. Pause if you need to slow down. Example 2. Given that angle E is congruent to angle H and EF is congruent to HG, here's my triangle. Triangles, excuse me. E, F, G, H, D. I want to prove that DF is congruent to DG. Okay? So I start with my statement, then I have my reason, and you always, always, always start with your given. Angle E is congruent to angle H. The reason, it's given. So angle E is congruent to angle H. Okay. Now, then I can say that EF is congruent to HG because it's given. So EF and HG are congruent. Interesting. I'm going to redraw my triangles to make it easier to see. So I have my big triangle here, EDH, and I know that these are congruent. I have my little triangle here, FGD, which I don't know anything about. Okay, and I have two side triangles, EFD, and GHD. I know that these are the same and congruent. Okay. Now, one thing that I can say is if I look at this big triangle, if I have two angles that are equal, I also know the two sides are equal. So ED is congruent to DH. Why? Definition of isosceles triangle, right? If I have two things on the base that are equal, then I know I have an isosceles triangle. Now, I'm going to draw that on these two triangles, so this and this. If I look at this triangle and this triangle, I can now say that triangle DEF is congruent to triangle DHG by side angle side. Pay attention to the order you're putting your letters in. It has to be consistent, okay? Since these are the same, I can then say that DF is congruent to DG, CPCTC. Congruent parts of congruent triangles are congruent. So nice. Okay, let me do one more. Okay, example 3. We are given that AG is congruent to EF and CA is congruent to CE. So I'm going to draw this figure. And I'm also going to say that B is the midpoint of CA and D is the midpoint of CE. That's all given. And we are going to prove that BG is congruent to DF. Okay? So first things first, statement, reason. My first statement is AG is congruent to EF because it's given. So make sure you draw that on your picture. AG is congruent to EF. Then I want to say CA is congruent to CE. Given. So I'm going to redraw my big triangle, ACE, and I know that those two are congruent. B is midpoint of CA, given, and D is midpoint of CE, given, which tells me that this segment is congruent to this segment, and this segment is congruent to this segment. Now, what that also tells me, if AC and CE are equal, then I know that angle A equals angle E. Angle A is congruent to angle E, definition of isosceles triangle. Okay, I'm going to move over here. Okay, which means in here and in here, I've got good stuff going on. Now, if I know that AC equals CE, and I know, so I can say AB equals BC, definition of midpoint, and CD is congruent to DE, definition of midpoint. I can also say that AB is congruent to DE because AC is congruent to CE. If that's true, I can then say triangle ABG is congruent to triangle, EDF by side angle side. Therefore, I can say BG is congruent to DF CPCTC. CPCTC is going to be your just savior throughout proofs, okay? It says congruent parts are congruent, triangles are congruent. If I say these two little triangles are the same, then all of their sides and all of their angles are congruent. I can say that for all things, okay? Proofs are hard because they require you remember the definition of isosceles, the definition of midpoint. All the definitions we've talked so far, you have to remember them and be able to apply them. We will do more practice in class and in your notes. Have a good rest of your night. That is all for lesson 9.